Insulin resistance is thought to precede the development of type 2 diabetes by 10 to 15 years. People get diagnosed with type 2 diabetes only when their blood sugar gets out of control. But what they are not aware is that type 2 diabetes and other chronic diseases happen over a period of years and decades. Researchers, doctors, and scientists have started to discover one major underlying cause of most chronic diseases: insulin resistance. Insulin resistance is a significant factor for various health complications, including cardiovascular disease and obesity. This video is an attempt to raise more awareness about the main causes of insulin resistance. So if you have nothing to do or are tired of binge watching the latest Netflix series, then grab your favorite beverage and let's learn about this silent epidemic. Data from a 2001 analysis found that 40% of the US adults are insulin resistant. 1 in 3 Americans are insulin resistant. It is a silent epidemic that needs to be tackled. According to the author of Why We Get Sick, Dr. Bickman concludes that too much insulin causes insulin resistance. Research indicates that for every 1 microunit increase in fasting blood insulin, a person can experience 20% increase in insulin resistance. This principle underscores a fundamental aspect of how the body operates. When you provide more of something, the body begins to resist it. This phenomena is evident in various contexts. For instance, over time, increasing caffeine intake is needed to achieve the same level of alertness. Similarly, stronger antibiotics become necessary as bacteria develop resistance to them. Likewise, prolonged exposure to loud music through headphones can lead to a decreased sensitivity to sound, essentially causing a form of deafness. So when there is excess insulin in the bloodstream, cells gradually become resistant, leading to insulin resistance over time. The main cause of insulin resistance is overeating, especially refined carbs and foods with added sugars. The 3 primary sites of insulin resistance are the skeletal muscles, liver, and fat cells. Around 70% of the glucose disposal happens in our muscles. Estimates suggest that our muscles can store up to 400 grams of glycogen. Liver can store up to 100 grams. Now, fat cells also have a limited capacity to store fatty acids. So what happens when you don't burn enough calories and keep eating? You're right, the muscle cells, liver, and fat cells start to become resistant to insulin. Remember the fundamental principle that a body operates on? When you provide more of something, the body begins to resist it. So through certain mechanisms and processes, the insulin signaling is decreased. In simple words, the doors start to close for glucose to enter the cells. What happens then? You get elevated blood sugar levels. Now, after years of being insulin resistant, you get diagnosed with prediabetes or reverse type 2 diabetes. Extra glucose floating around in the blood is not safe for the body, so that it tries to convert it into stored fat in non-fat tissues called etopic fat. This is when you get a fatty liver. Your body starts to store fat in your viscera, around your organs. This is the type of fat commonly known as belly fat or visceral fat. There are mainly 2 types of fat: subcutaneous fat, which is fat found underneath the skin, and visceral fat, which surrounds the organs like livers, kidney, intestine, and even heart. Research strongly supports the notion that visceral fat, particularly around the abdomen, increases insulin resistance. So location of the fat matters. There are 2 quick methods to measure your visceral fat. The first one is your waist to hip ratio. The second one is a bioelectrical impedance machine, which is nowadays very commonly found in the gyms. Obesity and insulin resistance are closely linked, and they often form a vicious cycle that worsen both conditions. So in summary, obesity and insulin resistance create a feedback loop. Obesity fosters insulin resistance, which in turn contributes to further weight gain, increasing insulin resistance. And breaking this cycle often necessitates lifestyle changes, including adopting a healthy diet, increasing physical activity, and achieving weight loss. Moving on, do genetics matter in the development of insulin resistance? I believe that they do play a role in health and disease risk. However, before pointing fingers at your parents, it's essential to recognize that your habits and lifestyle have a more significant impact than genetics alone. So yes, you may possess genes that hinder muscle building, impede fat loss, or elevate your risk of insulin resistance compared to your friend. Consequently, this suggests that you may need to put in more effort to address those challenges. So with this thought in mind, let's delve into 4 major lifestyle factors that can significantly reduce your risk of insulin resistance. And first is stress. Imagine yourself in the Stone Age, relaxing with your family after a satisfying meal. Suddenly a wild bear attacks your tribe, your body kicks into high gear, activating the stress response system, also known as the fight or flight response. This involves releasing stress hormones like adrenaline and cortisol to help you cope up with the threat. Adrenal quickly ramps up your heart rate, blood pressure, and breathing, prepares you for action. Meanwhile, cortisol mobilizes energy stores by increasing blood glucose and fatty acids, ready to fuel your muscle for a fight or escape. However, the action of these stress hormones temporarily make your body insulin resistant. This makes sense, right? During this stressful situation, your body needs the extra energy to fight the wild bear or flee if need be. So the fat cells, liver cells, muscle cells all become insulin resistant, which means they stop accepting the glucose and fatty acids. But you may ask this question, Akash, it makes sense for the liver cells, fat cells to become insulin resistant, but why does the muscle cell also become insulin resistant? Wouldn't it be easier for the muscle to accept the fuel via the action of insulin? The simple answer is that muscles don't always need insulin's intervention to accept glucose or fatty acids. It can accept glucose and fatty acid independent of insulin's action. So once again, during the fight and flight response, such as fleeing or fighting the bear, our muscle need all the energy it can. So the cells all over become insulin resistant so that glucose and fatty acids can be quickly used up by the muscle cells to get us out of the situation as quickly and efficiently as possible. That's why I always emphasize to people, exercise and physical activity is the best way to lower your blood glucose levels without relying solely on insulin. Now consider the stressors of today's world. We find ourselves stressing over trivial matters, work-related stress such as looming deadlines, job insecurity, and office politics. It can weigh heavily on our minds. Financial stressors like struggling to pay bills or save for the future adds to the burden. Relationship challenges are another significant source of stress. Now, these acute stresses can accumulate and become chronic. And in case of chronic stress, the body's adrenal glands continue to release stress hormones, mobilizing glucose and fatty acids for energy. However, in modern life, many stresses don't require physical action, like facing a wild animal. Consequently, the body's prolonged exposure to stress hormones without physical exertion can significantly increase insulin resistance and lead to various health issues. Please do note, cortisol has a direct impact on visceral fat. I've already created a video titled Cortisol Belly. Make sure to check that out. So when you compare two people who have the same body fat percentage, but the person who has more visceral or belly fat will be more insulin resistant than the other. Besides stress, next is sleep. Chronic sleep deprivation is associated with increased inflammation in the body, as evidenced by the elevated levels of inflammatory markers such as C-reactive protein and interleukin 6. Inflammation can disrupt insulin signaling pathways and contribute to insulin resistance. Sleep deprivation has been shown to impair glucose metabolism, leading to higher blood sugar levels and reduced insulin sensitivity. Studies have found that even short-term sleep restriction can lead to insulin resistance and impaired glucose tolerance. Sleep deprivation can activate the sympathetic nervous system, which controls the body's fight or flight response. Increased sympathetic activity can lead to higher levels of stress hormones and promote insulin resistance. As you can see, ultimately tackling insulin resistance boils down to managing your stress levels, your sleep, and also making sure that you live an active lifestyle and eat a plant-forward homemade diet. Now, before I end this video, I will say this again. Get your fasting insulin test done. If you have belly fat, are overweight or obese, knowing your starting point is important. Know your baseline and improve on that. I'm Akash. Thank you so much for your time.